Hello, hello. Welcome back to part 2 of the Unit 11 test review. So, we just did the first page, which covers all the solutions, molarity, dilutions, all that stuff. Now we're going to the acids and bases, and this is basically what we just did like 2 days ago with the quiz and all. So, a lot more problem solving here. So a lot of things to remember. So for this question here, it wants to identify, so in each of the following chemical equations, identify the conjugate acid-base pairs. Alright, so I always think of conjugate being opposite. So acid-base pairs. So in acid-base reaction, we have to remember that acids, we abbreviate acids, they lose hydrogen. Right, H plus, the hydrogen ion. Now, when the acid loses the hydrogen just, it doesn't go away, it doesn't vanish, it doesn't disappear, it goes somewhere else. So the acid loses it, or you can also say donates, it gives away the hydrogen ion. And where does it go to? It goes to the base. The base loves to get those hydrogens, so it gains it or it accepts the hydrogen. So think of it as the base is like, I want more hydrogens, I'm still hungry for more. Acids are generous, like fine, I have an extra hydrogen, you can have mine, and the base accepts it. So that's basically how these reactions go. And again, conjugate meaning opposite, so if there's an acid, it produces a conjugate base, the base produces a conjugate acid. So what happens when the hydrogen leaves and goes somewhere else? So what I like to do first is do a little match within the compounds. Use a different color here, not this color. Let's try green. So I can see HSO4 kind of matches with SO4, so they go together. And then that leaves H2O, goes with H3O, so the hydronium. And then you see, alright, what's going on with the hydrogens. So between HSO4 to SO4, the H went away, so it got lost. So that means the HSO4 is the acid, which automatically makes the SO4 the conjugate base. Because again, opposite. Water is, in this reaction, considered a base. So fun fact, water can be considered an acid or a base, depending on the reaction it's in. So in this case, it's a base. And since it gains a hydrogen, so notice it went from H2 to H3, it accepted a hydrogen, it becomes the conjugate acid. Okay, so that's how you do that. Alright, part B. So looks kind of weird because there's no H in front or anything, but again, you just count how many hydrogens. So obviously these two look pretty similar. Matchy here. Then HCl versus Cl. Okay, so now you're going to look at, okay, CH3, NH2. CH3, NH3. So instead of H2, it's H3. What happened? It gained a hydrogen. It had one more hydrogen, so accepted it. So it is a base, which produced a conjugate acid. So be careful. I've seen this before, that y'all know how to label acid and base, but then you think, oh, acid, base, conjugate base. No. Again, conjugate means opposite. So base to conjugate acid. Then that automatically makes HCl my acid, which we already know that because hydrochloric acid is the infamous acid. And then it lost the hydrogen, went from HCl to just Cl. It became the conjugate base. Okay? Alright, try to do part C by yourself. Pause the video. Well, let me zoom in actually. Pause the video and then play once you get it and check your work. Okay, so you should have gotten B, A, C, A, C, B. So this is acetate, acetic acid. So it went from COO to COOH, so it gained a hydrogen, so that makes acetate the base, and then automatically makes water the acid this time, and then the water lost the hydrogen from H2O to OH, so that makes it the conjugate base. Alright, next part, here's a different color this time. Let me try, I'm gonna use this one. Try this color. Okay, so now we're getting to the math, so grab your calculators. Alright, and you also need, actually, yeah, all you need is a calculator, and you have to know your equations, which it will be given to you, but you have to know how to use it. So you have your pH equation, your pOH equation, your H concentration equation. I know it's a lot, but it is what it is. And then your pH and pOH equation, 14, the pH scale. So I like to call this the bridge between the pH and pOH, from the acid to the base. Okay, so number 9, calculate the H in each of the following solutions. Indicate whether the solution is acidic, basic, or neutral. So we'll answer this second part in a second. We have to calculate the H first. That is our unknown here. So if we look at our equation, 10 to the negative pH, right? However, we have OH. What equation can we use to find? So, okay, let me rewind for a second. We need to find pH for us to plug in H. Okay, so that's the main step we need to get to, but we don't have pH. Can we calculate pH from OH? No, we can't, because pH goes with H, pOH goes with OH. Oh, well, OH is right here. I can find the pOH first, and then I can use my bridge to get to pH. So the first step is to find pOH. Negative log of 3.99. I'm going to do E. That's the calculator. Okay, 3.99 times 10 to the negative 5. So when you do that, plug that in, you should be able to get 4.4. Let me double check that real quick, because sometimes I mistype. Yeah, I got 4, so I'm going to round to one decimal place, 4.4. So now I can find pH from subtracting from 14. So 14 minus 4.4. So that should equal 9.6. Okay. Now I can plug this in to the equation that we want. H equals 10 to the negative 9.6. So that should equal 2.51 times 10 to the negative 10. And with concentration, there must be units. So big M for molarity. Okay, try to do this next one by yourself. Same exact steps, just different numbers. So go ahead and try it. Pause the video, then play once you have it, and check your work. Alright, you should have gotten 1.26 times 10 to the negative 13. So, how'd you do? I hope you found the pOH first, subtracted from 14, and then plugged it into the 10 to the negative pH. So that's how I got that. Alright, so for number 10, this is the other way around. For this part, you try to find H. Now this time you find OH, and you're given the H. So, same process, just like flip-flopped. So again, I'll do part A, and then you're going to try to do part B. So we have H, so I can find pH now, and then I can find pOH from the 14, and then plug it in to the 10 to negative pOH. So we want to ultimately get to this equation, but for us to get to pOH, I need to find pH. So pH equals negative log of H. So just plug in that number here, negative log of 1.27 times 10 to the negative 3, there we go. So you should get 2.9. Now your POH, you subtract from 14. You should get 11.11. And then that's when you plug it in here. So OH is 10 to negative 11.11. You should get 7.94 times 10 to the negative 12. Right, there you have it. Oh, I actually completely forgot to answer this part of the question. Indicate whether it's acidic, basic, or neutral. So, when it comes to this part, a lot of you guys missed it on that quiz. So, an acid is when it's less than 7. Base is when it's more than 7. And neutral is obviously 7. Okay? So, what number do you look at for that? You have to look at pH. pH for it. So, I have 2.9 as my pH. Therefore, this solution is acidic. Okay? So, let's actually rewind here. What solution would this be based on the pH? Basic. Basic. And then this one would also be basic because it's 12.9. Okay. There you have it. Alright, try to do this one. Again, same process, and also answer whether it's acidic, basic, or neutral. Okay, you should have gotten 2.51 times 10 to the negative 10, and just so happens the same number here. But the numbers are pretty close, so which is why I got the same answer, which is okay. Okay, so now that you found all the numbers that you need, you have to look at which one to find the acidity or basicity. You have to find, again, pH 4.4 is less than 7, therefore it's acidic. Okay, I hope y'all are getting better at this. You're feeling more confident. I know it's a lot of math, a lot of problem solving, but you can do it. Alright, so now this time you just have to find pH and POH. I think it's a lot simpler here because you just do like one negative log and then subtract 14. So it's just 2 steps here rather than 3 steps. So okay, since you have H here, again, H corresponds with pH, so you find pH first. OH corresponds with POH, you solve for POH first, and then you subtract 14. So, pH equals negative log of 1.21 times 10 to negative 8. You should get 7.9. That's part of it. And how do you find POH? You subtract 14. You should get 6.1. Alright, so now OH, you have to find POH first. Negative log of 0.1, which equals 1. That's POH. pH should be easy, just 14 minus 1, which equals 13. Alright, so part C. Try to do C and D by yourself. Pause the video and then check your work when you're done. Okie dokie. I hope you got pH of 3, POH of 11, POH of 12.7, and then pH of 1.3. Awesome. Same steps that I did. Alright, so I think this is the same deal here. Just like up top here, calculate the pH corresponding to each of the hydrogen ion concentrations. So you're given the H's, and tell whether each solution is acidic, basic, or neutral. So all you're doing is find the pH, and you have H luckily, so it's just a one-stepper. Again, pH is negative log of that H concentration So 0.00100, that should equal 3. So that's your answer, but then you have to tell whether it's acidic, basic, or neutral. So 3. Less than 7, excuse me. Therefore, it is acidic. Same thing here. Try to do this by yourself, and then pause the video, check your work. Okay, you should have gotten 10.03 or even 10.0 if you want, and it is basic because it's over 7. Alright, let's see how much we've got left. This is a lot of math. Okay, so this time you're given the OH and you're trying to find the pH. So what do you have to find first in order to get pH? So OH corresponds with POH, so that's negative log of that. So that should equal, 1 second, .4. And how do I get pH from the POH? Our magic number is 14. 14 minus 2.4, which equals 11.6. And is it acidic, basic, or neutral? Based on the pH. Basic, since it is higher than 7. Okay, try to do this one by yourself. Okay, did you get it right? 10, basic since it's over 7. Beautiful. Alright, so this next one, now you're just finding POH. Easy peasy. You have your pH, you need to find POH. What's the bridge? pH plus POH equals 14. You literally just subtract. So POH is 14 minus 6.49, whatever that is. POH equals 14 minus 11.21. So when you calculate those, 7.51, 2.79. Alright. Next part. Calculate the hydrogen ion concentration. So that just means your H. In moles per liter, that just means molarity because that's literally the equation of the big M. With each of the following pH values. So you have your pH. What is your formula for your H concentration? 10 to the negative pH. Luckily, you have your pHs already, so easy. 10 to the negative 4.11. So go ahead and find that. Get 7.76 times 10 to the negative 5 molarity. And then 10 to the negative 7 is literally just 1 times 10 to the negative 7. Alright. Awesome possum. Okay, so calculate the hydrogen ion concentration. So again, the H. If you have the POH. So again, H goes with pH. So how do I find pH from the POH? We subtract from 14. So 14 minus 3.91. That'd be 10.09. And then we plug it into the H formula, 10 to the negative 10.09, which equals 8.31 times 10 to the negative 11. Alright, try to do this one by yourself. Okay, you should have gotten 1.41 times 10 to the negative 13. Same process as before. Alright, cool. So this next part, okay, let me bring out these solubility rules sheets. Here we go. We haven't seen this in a while. Alright, so again, with solubility rules, it tells you whether something dissolves in water or not. So again, how you read this is you have these compounds, compounds that contain these ions, and whether or not it dissolves in water. So if you see ammonium, for example, NH4, it dissolves regardless. It's always soluble. So this light is kind of glaring. Let me see if this is better. I think this is a bit better. Okay. So this part says soluble compound, so like these dissolve regardless. But however, you have like bromine, it dissolves most of the time. It does not dissolve whether it's with silver, lead, or mercury. Okay. Other than that, it dissolves. Same thing with chlorine, iodine, sulfate. So if it has an exception, it's opposite to what it says it does. Okay. So same thing with this second half of the solubility rules. These are the compounds that are usually insoluble, that usually like sits there and does not dissolve. However, it has some exceptions. If it has exceptions, that means it does dissolve. So like compounds of ammonium, which is like, it makes sense because ammonium is undersoluble and it dissolves regardless, even if it has these. Okay, and then the alkali metal cations, that is group 1 of your periodic table. I don't have the other side. But yeah, group 1, like sodium, lithium, potassium, that group, they follow the exception. So they would be considered soluble if it's under here. Alright, so this is the confusing part. When it says S means solid. S means solid. So when a solid forms, that means it's insoluble. So S is insoluble. AQ means aqueous, so aqueous literally means dissolved in water, so it is soluble. Alright, so what you do is you see these compounds here, you look at the second half because that's the ion that we're looking at. So we have Br, and see where it falls. It's undersoluble, but however it has exceptions. And then you look at, okay, does potassium fall under those exceptions? No, it doesn't. So it's still soluble. Therefore, it's aqueous. Okay? Alright, PbCO3. So lead carbonate. So I'm going to look at carbonate. Carbonate is under insoluble. But is lead part of these exceptions? No, it's not. So it's still insoluble. So I'm going to put an S right by it. Alright, cool. Barium sulfites. So I'm just going to change it to sulfate because it's the same thing. But I don't know why they didn't include sulfite in the list, but same thing. So sulfates, SO4, it is undersoluble. But is barium one of the exceptions here, Ba? Yes, it is. So since it falls under the exceptions, therefore it is insoluble. So I'm going to put a solid. Forms a solid. Okay, try to do these 3 by yourself, and then we'll do some of these naming here. So these 3. Try to do this. Pause the video, and then check your work when you're done. Alright, you should have gotten solid, so insoluble, soluble, soluble. AQ. Alright, so I just want to talk about potassium hydroxide real quick. So, hydroxide, OH, it's insoluble, however, it has exceptions. K, potassium, is one of the exceptions. It falls under alkali metals, so therefore makes it soluble, so it's opposite. Okay, so for these other ones, you gotta know your naming, so which we did before. So zinc hydroxide is that. So you have to look at hydroxide, OH, considering if it's like soluble or insoluble. So I'm going to look at OH. It falls under insoluble. Is zinc one of the exceptions? It's not. So it still is insoluble. So solid for that. Alright, sodium acetate. So acetate is actually if you look at your special list, acetate C2H3O2, which falls under here. It is soluble no matter what. So I love that. That makes things so much easier. AQ. Same thing with this one, acetate, AQ. Okay, try to do this one, copper 2 sulfide. So sulfide, we know that's S, right? And then we look under sulfide S, it's under insoluble. Is copper one of the exceptions? It is not. So therefore, it is insoluble. I'm going to put an S right there. Okay? It's very puzzly. It's very like flip-flop. So you got to be careful to read this carefully and slowly. All right. Okay, so this last part, and I think that'll be the end of the video. This video's been pretty long anyway. So using the Arrhenius definition, classify the following examples as an acid, base, or salt. So when it comes with Arrhenius definition, just we know acid has an H in front, base has OH at the end, and salt is when you have your metal, non-metal. The ionic compounds basically make it a salt. Okay, so you literally just label whether it's acid, base, or salt. Pretty simple. HCl, hydrochloric acid, obviously an acid. Lithium bromide. So, I mean, my trick is if there's no H or OH, like neither of these, then it's obviously a salt. So there's that. And lithium is a metal, bromine is a non-metal, so they bond to make a salt. Alright, next one, magnesium hydroxide. Oh, we got OH in there, so it is a base. Same thing for part D. Aluminum hydroxide, so OH, that would also be a base. That would be B. Alright, so that concludes the part 2 of the test review. So I hope that helps. I hope you're working this out with me, especially with all the math. It doesn't really help by just watching me do it. So I hope you got a lot of these right and makes a lot better sense. But yeah, if you have any questions, let me know. Have a great day.